Experiment 4. Determination of heat of neutralization. As you can see on the screen, neutralization simply is the reaction that occurs between an acid and a base, giving salt and water only. Now, today we are looking at the heat of neutralization that occurs or that is given out when hydrochloric acid reacts with sodium hydroxide solution. Now let's look at the manual and see the explanation that is given. The enthalpy change of neutralization, the standard enthalpy change of neutralization, which is indicated by delta H neutralization, is the enthalpy change when a base reacts with an acid to form 1 mole of water under standard condition. And when you're talking about standard condition, we're talking about the concentration, the temperature, and the pressure. Okay, that is under STP, standard temperature and pressure. Alright, neutralization between a base and an acid, as I said earlier on, gives salt and water. But it is not the product we are looking at. We are looking at the heat change that occurs when these two substances are mixed together or when they react together. Now, the relevant enthalpy change is determined by recording the temperature change when two substances are mixed or when a set of mass of water is heated. That same formula we use for heat of solution is still the same formula we are going to use here. E equals mc theta or Q equals mc theta, where m is the mass, your C is the specific heat, and the T is your temperature. Okay, the procedure is given in the manual. Now, there's a difference between the data here and the heat of solution. In the heat of solution, you were given 50 cm cube of distilled water and you were asked to dissolve 1 gram of sodium hydroxide pellets. And I told you there that you were meant to use the 1 gram of your solute and not the 50 cm cube of distilled water as your mass to calculate for the quantity of heat of solution. In this case, 25 cm cube of HCl, that is the volume of the acid given, reacts with 25 cm cube of sodium hydroxide, which is the volume of the base given. Take note, the mass here is the addition of both volumes. This is the third assumption in calorimetry. Volume is taken to be the mass of the solute. That is, if your solute is coming either in liquid form or in solid form, you can either use it as gram or use it as volume, indicating the status of your solute. But in calculation, either volume or mass, you take it as gram. It's alright. So here we are having 25 plus 25 to give us 50 gram of our solute. This time around, our solutes are the addition of both the hydrochloric acid and the sodium hydroxide solution. So to calculate the energy required for the reaction above, the reaction is given on the screen. As you're looking at the screen, this is the reaction HCl plus sodium hydroxide to give you sodium chloride and water. And the delta H for this particular reaction is 57 kilojoule per mole. Alright, now in our own, it depends on the mass of your acid and the mass of the base that is given. So in the next slide now, we are going to see how the calculation is done. Please, you have to take note of your initial temperature and the final temperature because you need your temperature change to calculate. You need to monitor the temperature rise as those two substances react together. You have to take note of your observation and take note of the assumptions that you make. Alright, let's go to the calculation part now.